Things on the calendar. There's really two things I want to do today. One is to review kind of what we've been talking about the last 2 weeks, review some of the material from Unit 3, and then to, get into this new topic called something called Firebase. So that's really what we're going to be doing today is getting started with that. Okay. So the format I want to kind of do this in, the review, I'm going to do this in kind of a lean coffee sort of format. I'll talk about that here in a second. But basically, I'm going to have that kind of driven by you as far as what things we cover and what things we talk about. Okay, I want to keep it, maybe under 2 hours, but take some time to kind of review all the stuff that we built up so far, because it will go forward with the different things we're going to do with Firebase and such. So things we've covered in the last 2 weeks as far as Unit 3 goes. We've talked about how to connect to the internet, how to make HTTP requests, how to use background threads to make those requests. We looked at permissions we need to add, namely internet permissions and view network state. Those were the two things that you'll have to remember to continue adding to your projects going forward, because all of them going forward assume that they will need internet access for some way, shape, or form. Okay. We talked about threading a bit. What is the idea of threading? What does that mean? What does it mean to run multiple things at the same time? Multi-processing. We talked about this idea of the main thread versus the background thread and why we needed to put the network request onto the background thread. We talked about how to monitor the network state and connectivity, namely using the connectivity manager. So we walked through that there. We talked about a few third-party libraries. Things are not built into Android, but are really helpful and we use a lot. So we talked about Retrofit, JSON, and Picasso. We will be using Retrofit a little bit less as we focus on Firebase, but we will still be using Picasso anytime we need images to be pulled and downloaded. Architecture components, we kind of talked about how the new way of structuring our apps is. We talked about the idea of the data layer and the UI layer and kind of separating those, putting different pieces there, making classes. We'll continue with that process. We'll continue breaking up our apps that way. We talked about how to use view model and live data in that context to help with that separation. We talked about, on Thursday, we talked about how to implement a recycler view, how to create an adapter, how to create view holders, item layouts to go with that. Through that process, we've really started learning and refreshing also on creating classes. That's one thing that obviously before this session, we really had been kind of doing everything in main activity, and now we're at a point where we have, if you look at your app, you should have 6 to 10 classes in there now with that eBay application. So we're starting to come back to that, those classes and object-oriented programming that you got introduced into in second semester in the C# class. So we've talked about some of those things. That's a good place to ask questions if there's anything that you don't remember, because those are things that we'll be continually dealing with more and more classes. So if there's any questions or things that we need to discuss, those are good areas to ask those questions. We've also started using lists to pull the data, both from the API, and I went through that movie list example of adding or removing things, so we're starting to see that. We've seen a lot more with generics, because we were using live data, readable live data, recycler view, adapter, list, and array list, and all of those are generic in some form. So generics is a really important part of modern development with Java. Okay, so that's kind of a broad overview of things we've covered, things we've touched on. What I want to do is kind of open the floor for everybody to kind of suggest a topic if there's a question or something you want to go deeper in. What I'm going to do is I'm going to hand out some Post-it notes, and what I want you to do is pick out 2 questions. So you're going to write, you're going to put 1 question per Post-it note, period, and then we'll kind of arrange that and figure out where we're going to spend our time for the review as far as that's concerned. So we're going to kind of make that student-led. Cool. All right. Evan, I know you're not here today, so just send me the two over Discord, and I'll add them to the whiteboard. So. One question for So you get those figured out, you can just pull them out, take them up here, stick them on the whiteboard, I'll kind of arrange them and figure out how things cluster. Yeah, anywhere on the board. Can you phrase those in the sense of a question that I can answer? Yeah. I mean, those are good topics, but I need a question that I can answer one way or the other. play Okay. Okay. So first pass I've done is to kind of group the questions into topics. So you can kind of see that on the board. The next thing what I want to do is to kind of prioritize the things that are most burning because our time is limited. I need to kind of put a prioritization on there. So what we're going to do is we're going to have everybody vote. So the way this is going to work is you get to vote for 2 items. Put 2 votes on the question that's most burning that you really want to answer to. 1 vote on the second most burning. That's it. So you're going to put 2 hashes on one card and 1 hash on another card. Go for it. Evan, unfortunately, I don't have a good way to share that for you. So 2 votes on one card, 1 vote on another card. If you can, put it on the actual card. If you can take a pen and put the notes on the card, if you're really looking for individual questions. Okay. So clearly that's where we need to start. And the next topic. And okay. So a few things to start with here. So the first thing we want to talk about So Evan's question was really what's the story with live data versus mutable live data. So one thing to clarify there, live data is an interface, and mutable live data is a class. Live data is an interface, mutable live data is a class. So live data just defines the kind of how that's supposed to behave, how something that's live data should behave. Okay. Actually, let me double check that. Because I think they might actually both be classes. So Android developers. Let's just look up the class docs for it. I'll add that link here. So if we look at the documentation, so it is a class. So they're both classes. Difference being the live data is abstract versus mutable live data is concrete. So I can't create an instance of live data directly. It's meant to be subclassed. So mutable live data is a subclass of live data. Okay, so mutable live data is a version of that that's storing it locally in memory inside of a variable. Okay, it's the easiest one to use out of the box, right? It's the easiest one because it already just gives you the full implementation. Okay, live data, on the other hand, is something that you can create custom subclasses to kind of transfer, say, hey, I've got this other API, this other tool I want to use that already somehow keeps track of data and sends out events, and I want to turn that into a live data that I can use with the rest of my application. So it's kind of a way to transform it into this architecture component, because there's a lot of things that were built before live data was a thing. So that's one part of it. The other side of it is just that if you're looking at live data, it doesn't tell you any sort of implementation details of how that state's being stored, which for the observers, you really don't care, right? If all you're trying to do is observe the data and see that there's new events, then it should then all you're needing is a live data, okay? Mutable live data adds the two methods that we need in order to change the value inside. So both post value and set value, those are only available through mutable live data, okay? Only mutable live data has post value and set value. That's really the big difference, okay? And so that means if it's mutable, then I can change the value, but if it's live data, it's effectively readable. Does that make sense? Right? If it's mutable, I can read it and write it. But if it's live data, then if it's just live data, I can only read it. You're also asking a question which I think is related here to this whole type argument, right? So here, if we look in the docs, you can see it says live data T, right? Remember, that's a generic type argument. It's basically, we have function parameters, right? You can pass data into functions. You can pass values, but you can't pass types. So these type arguments allow us a way to provide types, basically types as arguments, as parameters to the class. So that means we can do things like, hey, I don't want to have to build a live data for every single data type that exists or will ever exist. So I don't want to build an integer live data and a Boolean live data and a float live data. If I didn't have generics, I would have to build all of those. Does that follow? If I didn't have this as generic, we would have a bazillion different live data implementations. And let's say you want to now observe your eBay products, your bugs. You would need to build then a bug live data, right? You would need to build a type for every data type, right? So that makes this more reusable. I can now store whatever kind of data I want, but it's still, as we would say, type safe, right? We're not saying live data object, right? And you can just stuff whatever object you want in there. It's limited to only holding the type that we set. So if I say live data integer, it's a live data that can only hold integers. There's a live data string, it can only hold strings. Does that follow? So that's kind of the idea of generics, is that you're getting a whole bunch of code reuse, and you're also getting type safe behavior at the same time, right? It's both sides. There is one weird thing in Java about how generics work. So in the C# world, you can actually use any types you want. You can use primitive types, you can use object types, reference types, value types. You can use whatever you want as those type arguments. In Java, you can only use classes. You can only use objects. You can only use reference types. Those are the only things that are permitted. Because of the weird way, and this has come down to the weird way that the generics are implemented in Java, okay? So generics are implemented in a very kind of odd way, okay? The reason that they're odd is when you run the program, the generics don't exist. The generics in Java only exist at compile time, not at runtime. What do I mean by that? So let's say I say that I have a live data integer, okay? So as far as I'm programming, as far as I'm compiling, I'm saying I can only put integers in there, okay? And it will enforce those constraints. But when the program runs, and what it compiles to is actually as if that type argument was object. It actually runs as if that was object, not if it was the type argument that you put in there. So those types do get used to help with type safety, but only while you're writing the code, only at compile time. They don't get enforced at runtime. Okay? It's weird. But because of that, that's why everything has to be a subclass of object, because it presumes that it's object when it's running. The reason they did that is to make things compatible with Java 4 and prior when this was introduced in Java 5. They wanted it to still be able to work with old code. That's why. Okay. And unfortunately, even we're 17 years down the road from when generics were added to the language. That still hasn't changed. So that's still a way that things operate. Okay. Anybody else that had questions on that? Mutable live data. Any other questions outstanding? Does that kind of answer that? Evan, you were the one that answered that, asked that. Cool. Okay, so let's look at the next topic. So, next topic. And I'm going to go ahead and add a link in here to both of those classes. Next question. So, the question is, we've introduced and we've added recycler view. Before that, we were using scroll view to scroll through things. And is there ever a time that we should use scroll view now instead of a recycler view? And I'm actually going to throw that out to the class. What do you think? Are there any cases where we should use scroll?
I would think that scroll view would be ideal for like if you're reading like text, and then I would think like recycle view is like I guess if you're viewing like a list of products or like all the kind of stuff like that.
Mm-hmm. So what do you mean text? Like a text view, right?
Yeah, like if I'm reading like an article, like a blog post or something, or
Yeah.
something like just a wall of text.
Right. So if I just have a wall of text, a giant, very tall text view, right? Recycler view is a lot of work to set up just for that, right? But that being said, let's say I have one giant text view and I've got a scroll view on that, right? How efficient is that going to be? Remember that everything in a scroll view has to be in memory, right? So if I've got that giant text view, all of the text has to be in memory and the text view has to be in memory, right? The text view is pretty cheap, like the view components are pretty cheap, but that does mean I have to be constantly rendering that entire article, the entire string, right? But is the entire article ever actually on screen? Probably more than likely not, right? If I was thinking about something like a review, then obviously that's fine. It's not long enough. I would just do that as a text view and maybe put a scroll view on top of it. But if we're talking about an entire article, that's not really efficient, right? So if I'm talking about the entire article, I really need to break it up. I need to break it up into smaller chunks. So an easy way to break it up might be to say, hey, we're going to break it up by paragraphs, right? So maybe every paragraph is a text view. Oh, and then maybe this kind of becomes a list, and then maybe actually recycler view is better, right? So if I'm talking about actually reading an entire article, I would actually still want to go back to recycler view. I'd want to pre-process that text to actually turn it into a list of paragraphs and headings, and then render that using a recycler view. Does that make sense? So it really depends on how big that text is, right? If it's an article with many, many paragraphs and many headings, then a recycler view is still a better choice. It just requires quite a bit more work to get to that point, right? That's the other side of things, right? How easy is scroll view to set up? Drag it in, drag and drop, you're done, right? So setting up a scroll view is very, very easy. That's one of the benefits. Setting up a scroll view is very, very easy. It's just not as necessarily as performant, right? So the question is, there's kind of a trade-off in it takes more work, more developer time to set up a recycler view, and it takes less developer time to set up a scroll view. Versus performance-wise, resource-wise, the recycler view is cheaper on resources. The scroll view is more expensive on resource. So it depends on, are you trying to optimize for developer time or runtime? If I'm trying to optimize for runtime and smoothness, then I'm going to reach for the recycler view. If I'm trying to optimize for developer time, I'm going to reach for a scroll view. Okay? So that's where I say, when it comes to articles, it's one thing. If it comes to reviews, I'm going to opt for just a text view. Does that help? What was the other thing you mentioned? So the other case, you talked about text views. I think you had two things, right?
So I just said like maybe a recycler view would be ideal, like maybe if you're scrolling through like a list of products or
right.
something.
And that's a case of, if I'm scrolling through a list of products, it's pretty clear cut because I want a separate layout for each thing, right? So one of the things we automatically get with a recycler view is a dynamic layout for each item. Versus if I'm using the scroll view, I kind of have to code all of the layout ahead of time. I have to know all the items in that list, right? So a scroll view kind of presumes that you already know everything that's going to be on screen. Versus a recycler view assumes, I don't know, I'm going to get a list of arbitrary length, I'm going to put that in here, but each item in that list is going to have some sort of normalized layout, right? So that also means things like, hey, if you have things that doesn't really have a normal to it, where every little item is different, maybe you still need a scroll view. Maybe you should still start there just from a developer time perspective, right? So, one thing I would ask, let's say we talk about the mortgage calculator app. Recycler view or scroll view? Which should we do? you did it with a scroll view, so it can be done. It could also actually been done with the recycler. But how would I have had to structure that recycler view? What are the items in the mortgage calculator? You got principal, you got tax rate, you've got, yeah, they're like input groups, right? So like you've got a label and an edit text, text view, edit text, text view, edit text, text view, edit text. There's a lot of similarity there, right? You could represent those inputs as items within a recycler view. You could totally do that, right? So your inputs are effectively the list that you're rendering. You might not actually save it as a list. You might do something more interesting with your adapter, because that might not make sense to actually model as a list, right? You might have a very custom specialized adapter for that, but you could do that, right? But start to think like, okay, how much more code does that take, right, to set that adapter up? Because it's quite a bit more complicated, and there's quite a bit more things details you have to figure out, right? So you could build the mortgage calculator with a recycler view, but it will for sure take a lot more work. Hands down, it will take more work to do it that way. So what's the benefit? Well, benefit is in terms of performance, right? Is it going to be more smooth? Do you get a benefit of saying, hey, maybe there's not all those inputs are visible all at the time, so maybe I'll just render the ones that are on screen, okay? Well, in that case, there's only 6 inputs. How many of them did you have on screen at the lowest point when the keyboard's up? How many inputs were you able to fit on the phone? Probably 1 or 2, right? So if I think about the phone layout and that, okay, well, so there's 1 or 2 odd visible, and then the other 4 are not on screen. So maybe I can save a little bit of time by not rendering those. But for that small number of inputs, I still don't see the benefit, right? Let's say it's something more complicated. It's a registration form. And maybe it's a registration form for the IRS. So it's got 50 inputs. Or it's some sort of questionnaire, right? Maybe it's a personality quiz and it's got 50 questions. If you've got 50 questions, then a recycler view makes sense, right? If you've got something with 50 questions on it, or some sort of form like that, I should transform that into recycler view because there will be a noticeable impact, right, of doing that versus a scroll view. Does that make sense? So part of it depends on how big is it, right? And how, is the developer time worth that, right? Is there going to be enough user impact for me to even take that 50 questions, right, turn it into a recycler view, right? If it's some sort of questionnaires where those questions are dynamic, well, then the answer is obvious. It's a recycler. But what if it's a registration form and you know all 50 questions ahead of time? They're always the same questions, right? It's maybe more of a toss-up. So yes, it's an easy break is if it's dynamic, it's probably the easiest way to go about it is just to jump to recycler view. If you've got dynamic data, I would just jump to the recycler view. But static is a little bit more of a gray area. Static, usually you can start it with a scroll view, but if you have a bunch of static inputs, 50 static inputs, somewhere on that range, it may even be as much as 10 where you start to make that consideration, right? If I've got 10 questions or more on my, input fields or things like that, I might consider already breaking it up. Cool. You had a hand up earlier. I didn't get to you yet in terms of this. Recycler view versus scroll view. Okay. Does that kind of make sense? So the reality is you're still going to use both, right? It's just a question of what are you optimizing for. So another good example might be, let's say I'm looking at the product list, okay? Well, obviously the product list or the product search page, that's going to be a recycler view. What about the product details? Recycler view or scroll view? Say I pick a product from the list, go over to the details page. What should I use there? Why?
Because it's finite amount of details.
Yeah, it's going to be a small amount, right? So I would start with a scroll view if I was looking at the product details page. Okay, in general, that would be a good starting point for product details. Say, hey, it's probably a scroll view is a good fit because it's a small amount of statically laid out stuff. Let me throw some curveballs there. Product details page. What if I want to have 5 to 10 images available for that product? Scroll view or recycler view? How would you handle that? So, Evan, you're saying recycler view, and why? Why might a recycler view be helpful? Well, if we think about it, right, here's the way that I would kind of lay that out. I would say overall, we've got the product details screen, right, and that probably has some sort of scroll bar to go with it. Okay. Up here, horizontally laid out, I might have a series of images that the user can swipe through. This part, where the images are, might be a recycler, and the whole thing, though, might be a scroll view. So actually, on the product details, you'll often find both. Whole thing being in a scroll view, but the images are in a horizontal recycle view. Does that follow? What else might commonly be on the screen? So we've got the images. Say we go to Amazon. What other things are on their product page? We've got the text, the description of the product. But what else? The reviews. Okay. Do we know the reviews up ahead of time? Do we know how many reviews there are going to be? Is there a limit on the reviews? So none of those things apply. So in reality, we probably see some sort of other recycler down here for the reviews. That would probably be its own recycler to look at the reviews. So the answer is both and, right? You're going to probably have a scroll view as well as a recycler. And you might well have more than one recycler. Yeah.
So what about like
You said if you click on them?
Like if you go to the Amazon page, like a bunch of images,
yes.
Go along with it?
Yep.
Is that just going to the
that would be like if you can swipe left or right to them, it's probably recyclable. I know specifically Reddit's kind of that way, right? You can go to the story if somebody's posted an image and swipe through the top images, right? So there's a recycler view at the top of the post, okay? Both, I think, with Amazon and with Reddit, you can click on it and it'll expand, right? So you're kind of going into another screen, but that screen also that new screen is just recycler view. Like, so you tap on this, goes to another screen, that other screen is just a horizontal recycler. That's all it is. Does that make sense? So So you have one here basically for the thumbnail. You click on one in there and it would take you to a full screen with the larger images. And that's still recycler view because you can usually swipe through. Cool. Does that help a little bit to think about it? The answer is both. The answer is it's not going to go away. We're still going to use scroll view. It's just maybe more rare, right? In the sense that, like, per screen, you usually only have max one scroll view. You usually only have max one scroll view. You might have a bunch of recycler views. You're going to have maximum one scroll view. Okay? Cool. There's another control that I might mention while we're talking about this. There actually is something called a nested recycler view, or not nested recycler view, nested scroll view. It's a topic for maybe another day, but it's something worth looking into. So a nested scroll view is designed to work with other things that are scrolling. So for instance, actually in cases like this, the product page, it would actually be more common to use a nested scroll view as the larger thing, and then rather than a scroll view, because we've got those recycler views inside. And so a nested scroll view is designed to work better with other things that may be scrolling, other things where you have a scroll view or recycler view inside of that. Okay, so that's a little class that exists, another component that exists in the Java world, Android world, but it's something we'll probably come back to later. Okay. Does that help kind of thinking about some of those details, right? Again, it's both, and there's just a lot of cases where you're going to see either one. Next up. Can you go over class creation and class use? Okay, so talking about classes. I'm going to pull up Notepad just for illustration purposes. Create a new tab, new file, go to language, go to Java. Okay. So let's say I'm creating a class, public class. Let's call this product. So at a very minimum, at a basic standpoint, that's all you need to have to create a class in Java. Everything else is optional. Okay, everything else from there is optional. Okay, this is the only part that's required. Now, you might notice that there's a keyword. I already started with the keyword public on. Okay, classes do have an access modifier. Okay, that access modifier says what other classes can use this class or have access to this class. If we mark it as public, public says that any other class in our application can use this class, which is normally what you want. Normally what you want is I can just say any other class in my application can use this. So it's a good place to start and just assume that your class should be public. It's very rare that that will betray it. It's very rare that it's worth using any other access modifiers. Okay. Now, what if I had written as this? What if I left the word class? What if I left the word public off? This is called package access. Okay, if I leave the word public, then only the classes in the same package as it can use this class. Any classes in a different package can't use it. So for instance, let's say I've got my data package and I got the UI class. I've got this in my data layer, okay? Well, that means nothing in my UI layer can use this class because it's limited to just that package, okay? So this is generally not what I want. Does that make sense? That's generally not what I want. The one reason that I might use that, the one reason it exists, is occasionally you find cases where I might want to say, well, this is part of the implementation details of this thing, and so I don't really want to expose this. Use this public class instead, and this is kind of that public class uses the package private class. So you use the public, which uses the private, which uses this one. These won't really come up for us. That's kind of an architecture and a detail that I think doesn't make sense at this level. Cool. Okay, but it's really important that you make sure you mark it public. There's also a rule in Java that typically, when I create a new class, that file can only, whatever class is in there has to have the same name as the file. So if I create a product.java, it has to have a product class in it. It can't have the foo class instead. It has to be named the same name as the file. And that class has to be public. Now, it turns out in Java, it is valid to put two classes in here. So I could do something like, here is the product that's public and the review that is package access. I could put those stacked on top of each other. You are allowed to have multiple classes in a single Java file. The rule is only one of those can be public. All the rest of those have to be package access. Don't do this. Forget that you can do that. You can, the Java language does allow you to do it, but you never should. You can put multiple classes stacked on top of each other in a single Java file, but you shouldn't do that. And to answer your question about Evan's question, he says, can we place a recycler view wrapped by a scroll view? And the answer is yes. We can nest those things inside. Okay. So we really want to make sure that we have the access modifier on there. If I have, what about this? Can I put the word private in front of a class? At the root, no. At the root, this is not legal. Okay. Private is only legal if it's a nested class. Okay. This is only legal for nested classes, not for root classes. Okay, or not, I think they call them top level classes. Okay, but if we have this nested inside of something, then we're going to say, well, that means that this class is only usable or accessible by the class that's inside. Class that's inside is the only one who has access to it. Make sense? In terms of access line first? Okay. Now, what are the things that we can put inside of a class? What's usually the first thing that we see inside of the class? Because there's a convention to the ordering. So yeah, so instance variables and constants. Actually, usually in the order, constants, and then instance variables. Okay. So I might have in here public static final, maybe call it string, and what do I want to call this? It might be a constant. Let's say we'll go with our convention, and I do log tag. Okay, so that would be a constant, right? It's not going to change. Versus if I had an instance variable, okay, I might write it like so. Okay, so I've got a constant and I've got an instance variable. Difference being constants, you'll see this keyword static and final. Static and final in the Java world is the way we define something as being a constant. There is no const keyword. So static meaning that there's only one instance of it, period. There's not one copy of that variable for every instance of product. Every product has the same log tag, and final meaning it can't be reassigned. Okay? So both of those two things together basically get us to a constant. In some way, that's kind of a constant already, right? Without the static keyword, right? Its final says it can't be reassigned. So that kind of is really the part that makes it constant. But without the static keyword, then you're creating this memory, using this memory for every object. So if I've got 100 products, then I've got 100 strings that all contain the word product, right? So really adding the word static there just serves to make it have fewer copies in memory. Okay. It also serves to introduce potential race conditions, because now anytime I refer to that log tag variable, I'm referring to the same instance, and so I have to be careful about all my threads are sharing that one object. Okay, so that static variable, static is something that I have to watch out for in terms of race conditions. Okay, strings are safe because they are immutable. I can't change the string. But anything that is immutable, if it's got setters, if it's got fields that can be changed, you really don't want to mark it static. Okay? That's usually the dividing line. Immutable things can be sometimes safe to put in static variables. If it's not immutable, try to stay away from that. Okay, so I can have things like, actually I want to put name here, and maybe I do private double price. So I have my constants, I have my instance variables, what else might we see? So how do I initialize these instance variables? How do I initialize those instance variables? Remember what the term for that is? How do I initialize those instance variables? What do we call it? Same thing as it is in C#. Yeah, the little constructor. So how do I define the constructor? Well, I have to give it an access modifier. Typically, that access modifier will be public. Typically, you want to make it available. So public product. Now, if it takes no arguments, we call that the default constructor. Okay, so this is the default constructor. Every class starts with a default constructor. Okay, start with the default constructor. And so even if I don't specify this, this is kind of implied. Does that make sense? The gotcha is if I define another kind of instructor, any other kind of instructor, this goes away. There's another gotcha with constructors. In this case, I don't have a parent class. If I had a parent class, then I would inherit its constructors. Does that make sense? If I have a parent class, then I inherit its constructors, and I have to work with that. But since I don't have a parent class, we're fine here. If I want to add another constructor, so this is default constructor, I might add another constructor. Call this the overloaded constructor. And product. This takes string name, double price, this dot name is equal to name. This dot price okay. So now this class has two constructors. One that takes no arguments and one that takes multiple. Okay. Now implicitly this constructor, that default constructor, is setting all of these things to their default values, right? So if I don't put any body in there, these things are still being initialized. So this dot name is being initialized to null, and this dot price is being initialized to 0. Okay, those two things happen even if I don't write them. Okay, but if I wanted to start them out as a different value, say I want to start the price out at $5, then I would need to define that in the default constructor. Important note about the default constructor. The default constructor is often used for I/O. Often, if we're trying to transfer data across the network with Java, the default constructor is often used as part of that transfer process. So if you're going to send the class over the network, it needs to have a default constructor. Just go ahead and assume that. Okay. The good news is, again, it gets that without you having to write one, but it needs that for I/O purposes. Okay. The other thing I would recommend from I/O purposes, it's usually better to leave this thing completely empty. It's usually better to leave this thing completely empty, again, from an I/O perspective. Yes?
So the default constructor, that's a getter, right? And then the one on the bottom is a setter?
No. Both of these are constructors. They're neither getters nor setters.
Okay.
They're neither of those. What they do is they construct a new object. So from calling either of these ones, I get a new product object. Okay. It's neither getting or setting. In some sense, you could say it's setting values, but it's not. So the typical right answer for dealing with transferring things over the network is usually that's the right way to just always write your constructors. Is your default constructor should be like that. But you might notice in my examples I didn't write that because it's implied. Okay? I left that off of some of the classes because it's implied. But you'll see this pretty often. Okay? Questions so far? Okay. Now, next thing, getters and setters. So how do we write a getter? So let's say I want a getter for, I'm going to have a getter for usually all of the instance variables that we have. So public string name, public string get name. So convention is that. And that needs to actually return a double. Okay. So if those are the instance fields I have is name and price, then those would be my getters for those instance fields.
So those are just methods from those classes, right?
Yeah, they're just methods as part of that class. The reason I need these is because the fields are private. Because they're private, I can't directly get at the value, so I need to write a getter for the value. Similarly, because they're private, I can't set them directly, so I need some setters. Public void set name string dot name. Okay. So I've got my getters, which read the value of the field, and a setter that sets the value of the field. Okay. Notice that there's a definite pattern to this. Your getters and setters should follow that pattern. Please don't stray from that pattern. There's a reason that that pattern exists, and I would recommend if your function doesn't follow this pattern, it's not a getter. If it doesn't follow that pattern, it's not a setter. That's one thing that I found from the process of doing these things for years is if I use the terms get and set, there's an expectation from the person working with the code that that is what it's doing. So if it's doing something else, it should have a different verb. It should have a different noun. Sorry, a different verb. So for instance, if I wanted some method to say modify things, so maybe I have things like tax that are indirectly affected, I might use another verb and call that, say, update. So if it's something that doesn't fit into this pattern of like a simple setter, I might use the term update to say, or calculate, or things like that, to specify things that don't fit into that. Okay. Other things you'll commonly see as methods in here. Out of the box, a class, an object in Java has 3 methods. Okay, there are 3 methods that are built into all objects in Java. One of those is toString. Every object has toString. Every object has equals, and every object has hash code. Every object in Java has those 3 things: toString, equals, and hash code. Okay. Out of the box, they have an implementation. The implementation is almost garbage. For all intents and purposes, the built-in implementation of those 3 is something you basically never want to utilize. How do these work? So toString by itself really just gives you the name of the product, and oftentimes is some sort of value that will tell you like the reference, where the reference is in memory. But it's really gobbledygook. The default toString won't tell me the name of this product or the price of the product. Almost completely not helpful. Okay. Why does toString exist, though? Why does it exist? Why does every object have it? What is the purpose of toString? I'll give you a hint. The main purpose and the main reason every object has toString is not for your users. It's for the developers, right? So the reason that toString exists is actually for your IDE. It's not for your users. The reason that every object has toString is because when you use the debugger and you're stepping through and looking at things, it will use the toString to render that object. The toString is actually used by your IDE as you're exploring the values, as you're looking at what are the current values of those objects. So, what does that mean? That means we really should be avoiding using toString in our code because it's really, really, really meant to be there for the IDE. Okay. It does come up. There are cases where we use this, but I really only use toString if that is the only option, right? If that is the way they said, okay, well, you have to do this way. Like get text toString. Unfortunately, there's no other function that does the same behavior. There's not another function by the same. So that is the function we end up using. But oftentimes what we will do is we will override that default behavior. So I might say at override public string to string. And so I might return something like return product That's a pretty normal pattern, is to do this, which is great when you look at it in the IDE. Because then you see the product, okay, it's a product, I know what class it is, I know what the name is, I know what the price is. Like this is a really common pattern if I'm going to overwrite toString. But it's for the IDE, it's not for my actual users. My users shouldn't ever be calling that toString. Does that make sense? Sometimes, depending on what you're using, you might see this as if you're actually using this in code, which you shouldn't be. The places that are actually using this in code, this might just say return name. If I was actually using this somewhere in code. Like, oh, okay, well, maybe I'm rendering this in a list, and so that list is implicitly using toString to figure out the label of the item in the list. That might be something like a spinner or such drop-downs. Okay, but that's usually how I would implement that. If I need that from the debugging standpoint, right? So because it typically doesn't provide any value to the average user, to the average use case, I don't necessarily recommend adding toString to every class that you have, but I would recommend adding that to some, right? To some where that would be helpful. What about equals? So at override public Boolean equals okay. So equals, remember this is the method that we use instead of equals equals, the equals equals sign, like the comparison sign, because remember that in Java, equals equals just compares the reference, just compares where it is in memory, just says the references are the same. A scary thing is The default behavior of equals, if you don't implement it, that's what's in the base class. That's the normal behavior of equals unless you override it. You see the problem? So unless the developer of that class has actually gone into and implemented equals, it's no better. It's no better than doing equals equals, because that's the default behavior. So we're tracking that with me? So oftentimes I may need to go in here, and rather than just comparing those instances to see if they're the same, I might want to say, well, they're equal if the data is the same. Okay, so if I need that behavior, if I need to compare these things, then I'd like to effectively say return this dot name equals equals other dot name, and this dot price is equal to other dot price. Okay, that's effectively what I would like. Usually if I'm going to implement it, that's what the implementation might look like. Okay, it won't actually look like this because there's a few bugs right there. But that's my goal, right? So what are the issues with writing it this way? They're just saying the name are equal and the price are equal. There's two issues here. Enough that it won't compile. One preventing it from compiling, and one will give you a warning. What do you see? What can we use equals equals to compare? Do you remember? What can we use it to safely compare? Just primitive types. Yes, right. Are we comparing primitive types? Yes and no, right? Is the name a primitive type? Is the name a primitive type? No. Name is a string. It's a reference type. So that's not legal. Is price a primitive type? Yes. So price is a primitive type, so that works for price, but doesn't work for name. Primitive versus reference. I have to know that difference. If I'm going to implement equals, I have to know what is a primitive and what is a reference type. Otherwise, you can't implement it properly. So, what do we need to do for name? Because the name is a reference type. How do we compare the names? How do I change the code to do this instead? Okay. No, and there's no triple equals in Java. It does exist in JavaScript for a specific reason, and the reason it exists in JavaScript is because we have a loosely typed language, but it doesn't exist in Java. Exactly. So we need to use dot equals here, right? So notice that our equals also needs to call equals. This is a really common thing where you're inside of equals, you also need to call equals. Assume that some other objects have also implemented. So rather than writing it that way, I might say this dot equals other dot name, and this dot price is equal to other dot price. one problem down. We still have one unsolved problem, and actually there's a problem we just created. Actually, this should be this dot name. So a commonly overlooked problem is, remember that reference types can be null. This name could be null, or that name could be null. This name could be null, or that name could be null. Are you tracking with me there? Okay. If this name is null, the whole program crashes. We get a null reference exception. Because I can't call equals, I can't call the method on null. So what do I do if name is null? How do I handle this if the name is null? What would be the way you'd work around that? How do we keep this from crashing?
Could we implement like an if statement, like an else statement?
Okay. So where would that if statement go?
Well, before return.
Okay. So I'm going to comment that version out. If what?
So if this dot name is equal to null, then would it be dot equal to null?
So in that case, it would be a double equals null. Yeah. There I do need to specifically compare it with null, not using equals. Not using the equals method. If I try to use the equals method, I get the same problem. If I try to do this, it would still crash because name is null, and I can't call a method on null. So I do have to do that check with the equals equals. Okay. So I can start with an if statement. Anybody, what goes inside there? There's not just one answer, by the way, to how to do this. Log an error? Okay. Important thing, I'm going to make this really clear. Make a note of this. Okay. What are the three methods that I said that all objects have? ToString equals hashcode. Never put logs in any of those three. Period. Never put logs in any of those three. Wow. Well, ToStrings used by your IDE. That would mean you're logging every time you look at it in the IDE. It's also just the problem of when those things occur. Equals. If I'm, say, sorting a list or doing all sorts of other things with it, this equals is going to be called a lot. If you put an equals there, your program might stall completely because equals get called so often. The log will be enough to overwhelm it. And it might even flood your logs. It might even flood so many. If you put a log in here, it may well flood your logs to the point where your log cat crashes. Don't put logs in here. Okay, you can't. Okay, you can't do anything in here other than the comparison. Similar thing with hashcode. Hashcode is also often called pretty often. So we can't do any logging here. Okay?
Yeah.
Clear? It's called too often for us to do logging here. What can we do instead? What is our goal? The goal of this function is to return a Boolean that says if these two objects are equal, we return true. If they're not equal, we return false. Okay? So some way, shape, or form, we have to end up with true or false. Okay? This has to end up with true or false. Okay? So you're saying if the name is null, then these two objects are not equal. Correct? Is there ever a case where that's wrong? Huh? Right. What happens if they're both null? Then they're equal. Right? They could both be null. So it still sometimes could be true. So I can't immediately go to false. I can't immediately go to false because the other thing could also be null. Thoughts? How can I fix it? Under what conditions are they both, do they both have the same name? Well, I could say does that work? So if the first thing has a null name, I say, well, they're equal if the other thing also has a null name. Is that correct? If their names are both null, are they equal? What if one has a price of $5 and the other one has a price of $7? I'm not checking the price. Right? So that doesn't work because, the first issue is we can't return false, right? Because they might both be null. Second issue is I still have to check the price because they might still have different prices. Okay? So if I'm writing this with an if statement, this case becomes does that first part make sense? Now remember, this function always has to return a value. Okay? So it still doesn't compile because I'm not doing anything about the else case. Okay? So what do I put into the else case? What do I put there? So name's not null. How do I determine if they're equal?
Would it be line 58? Like that?
Yeah. Yeah. It's exactly line 58. Make sense? What if other.name is null? We checked for this name is null, but what if other name is null? Good news. Equals is already built to check for this thing being null and will return false. Okay? Because we're calling on an object that's not null, but that object is null. So this is safe. It's safe for the argument to equals be null. It's not safe for the thing before equals to be null. there's a weird asymmetric sort of spot there. Does that make sense for everybody? Okay. Does this look redundant? Does this look like I'm starting to write in some redundancy, maybe? Notice I'm comparing the price twice. This gets even worse. Let's say I have 5 or 10 different properties in here. This is easy because I only have 2 instance variables. But if I have the same thing with 10 instance variables, and all of those are reference types, then I have to deal with 10 if statements. Does that make sense? So ideally, and actually they would be nested, because I would have to go, is this one, is this, if they would be nested 10 levels deep, if I had 10 variables that were all reference types. So while I can write it this way, it doesn't really scale. It doesn't really scale. So let me give you a trick. This comes up enough that if I remember right, we look in the Java docs. There's a class called objects. Okay. Now notice the pluralization on there. It's not called object, it's objects. Okay. Objects has a bunch of static utility methods. One of them is equals. So if I go look up here, objects with an S dot equals has a version that takes 2 objects and returns a Boolean. The good news in here, this version works if either one is null. This one works if either one is null. It already takes care of that. So the pattern that I use, rather than doing that complicated approach, rather than taking the approach that we had there, well, I guess I got to do this the hard way. Is I just say return objects dot equals this dot name other dot name. That completely avoids the need to check for nulls. Is everybody following with me? So that's the way you work around it, is you just use this utility method that's out there to catch the null case and deal with the null case. So if one of these is null, but the other one isn't, this will return false. If they're both null, it will return true. Already takes care of it. So we'd actually prefer to use objects.equals instead of that pattern. This is actually always a better pattern, is to do the equal sign. Okay, everybody on board? Everybody on board? That still basically keeps it as one line, the benefit there. Now, this still does not compile. The reason being, other.name is not valid. Other.price is also not valid. Why? What type is other? Object. And it has to be object. We can't change that. Because the parent class object defines that that input has to be object. We don't get to change the type of it. But object doesn't have a name and it doesn't have press. It has no fields. So this is not valid. This would only be valid if other is what type? It has to be a product. Okay? So what I just said is I cannot change this word of product. It's not legal. Okay? Because the signature of this has to take an object. Okay? So what I have to do is I have to change this in some way, such as product, other product. I need a variable that actually is type product. One way to get that is to try and cast it. That's legal. That will compile. Because now the other thing is a product. I'm referring to other product instead of just other. Okay. But this presumes I'm comparing products with products. If the other thing I passed in is not a product, this crashes again. Not with a null reference exception, but with a class cast exception. It'll say, hey, this is an illegal class cast because other is not a product, right? If I pass a review into this and say review equals product, it will just crash. It'll just throw an exception. So what do? Well, some cases, exceptions, try catch, right? Sometimes that's the right answer. Not here. When we're talking about class cast exceptions, we want to avoid those being thrown in the first place, right? So I have to somehow say, well, if it's not a product, we want to do something else. So we're tracking with that? If it's not a product, I want to do something else. So I have to do something like this. If other is some subclass, right? It has to be product or some other subclass of product. I would say if other is an instance, one way to do this, old way of doing this, is instance of product that will tell me that that instance of is a special operator. It says this is either that class or some subclass of that, right? So this other is product or some subclass of product. Okay. If that's true, then it's legal to do the cast. So really what I'm concerned about is if that's not true. Right. Unfortunately, there's not an easy way to, there's not an opposite operator, there's not a not instance operator, so I have to not that whole thing. So I say if the other thing is not a product, then we can immediately return false. We can say, hey, they're just two different types, they're completely unrelated, we're done. Make sense? Okay. The problem that this runs into is that it doesn't work well for subclasses. So let's say I've got a image product, and image product also is a subclass of product, but it also adds an image. Well, those two things should only be equal. Those two products should now only be equal if they both have the same image. Okay? So I realistically can't compare an image product with a product, even though they're subclasses. Does that make sense? So really things should only come out equal if they're the exact same class. Are you tracking with me there? They should only come out equal if they're the exact same class. So while we could do that, it's really not ideal. So what I want to do instead is I say, I take a different tactic, this dot get class, And I just say, if the classes are all different in any way, then they're not equal. If their classes are all different in any way, shape, or form, they're not, we shouldn't treat them as equal to each other. So that's generally, so modern Java development, that's considered the right way to check. Is everybody tracking with me there? I'm just saying, are the two classes the same? It's a weird thing here because this does return a class object. So you would think that those are both reference types and I should use .equals. It turns out classes actually basically, for all intents and purposes, there's only one instance of. So if they're both product, it actually does point to the same product class in memory. So it's actually safe. It's safe to compare the references because there's only one instance of those classes. Okay, this, however, kind of like before, I just created another problem because I'm trying to call other get class. What if other is null? I know that this is not null because we're in this method. I couldn't have called this method if this was null, but other could have been null. Everybody tracking with me here? Equals is kind of tricky because there's a lot of things you have to watch out for. So we add another special clause and we say if other is null, okay? If the other thing is null, then they're definitely not equal because one thing is null and the other isn't. Or if their classes are different, we're done immediately and we know that they're different. Cool? Now, another shortcut we often put in there is that if I'm comparing an object to itself, is it equal? If I ever compare an object to itself, should equals return true or false? Or is it sometimes? If I say A equals A, is that always true, never true, or sometimes true? Aaron? Always. Why? Something's always equal to itself, right? The problem with this is if I screw things up, first of all, that might not necessarily be true if I'm not careful, okay? I could accidentally write this in such a way that it returns false for itself, so I do have to watch out for that. Also, it's kind of expensive. It's kind of expensive to go and compare the entire object when it's the same object. Does that make sense? It's kind of, there's a lot of comparisons that I have to do. So to go through each field by field, and say, are those the same? So oftentimes you'll see a shortcut up top. If you're comparing yourself, then just immediately return true. If you're comparing with yourself, go ahead and just stop. We know it's true. Does that make sense? So equals, the pattern is if we're implementing equals, we're always going to add these three special cases at the top. Okay? It applies for anything you're doing in Java. So we do those comparisons. We know after that that we're looking at two different objects. They're not the same object. They're not both null. And we know that they have the same class. So then we're safe to proceed like this. Cast it to product. compare it, say all the fields are equal 1 by 1 by 1. Everybody good with that? This is what it actually looks like. Notice where we started, right? Notice that we started with line 57. All of this has to do with just making sure that it doesn't crash, basically, right? To making sure that it's efficient and doesn't crash. So it's good. If you're going to implement equals, that's the pattern. Good news is IntelliJ will help you implement that pattern. If you, in IntelliJ, if you go in the Android Studio, start typing equals, it will actually fill out most of this for you. Okay, there's a reason that it does that. But the caveat is that's a lot of code, that's a lot of tests. I'm usually only going to implement that if I need it. I'm not usually in the pattern of oh, I'm going to implement equals for every single object in my program, because that's a lot of work, right? And it turns out that every time I add an instance field or rename an instance field, I've got to go update this method, right? So it also adds up there. Cool? Okay. What about the hash code thing? At override public int hash code. Okay. So that's the signature of hash code. It has to return an integer. It takes no parameters. Okay. The place that the hash code gets used is primarily with something called a hash map. Okay. So if you ever use this object as a key in a hash map, you do have to override this. Okay. It's also used in some other places as a shortcut, because hash code is much faster, generally speaking, than equals. Equals is pretty slow because of all this stuff. Mainly because things like this dot name, comparing this dot name with the other name, actually means we have to loop over and compare the characters by characters. There's an implicit loop hidden in there. So this method is not cheap, so we may use this method instead and say, oh, well, if the hash codes are different, then we know they're not equal. But if the hash codes are the same, they might be equal. That's basically the way we use it. We say if the hash codes are the same, they might be equal, but if they're not, then they're definitely not equal. Okay. So the default implementation here just generates a hash code based off of where it's located in memory. If you leave that in place, then that contradicts with equals. So if you override equals, you also need to override hash code. It's never safe to override just equals and not hash code. Both of them have to be in sync. Everybody following me with that? So unfortunately, it's like, well, okay, we got to talk about that. They both got to be the same. Okay. So turns out they're pretty easy to implement. And the trick is you use that objects method that we just looked at. So just like there's an equals method there, there's also a hash method there as well. And so you can go ahead and tell it to do the hash for you and basically produce that method. So this turns out actually really easy. Thanks to that. Done. Just take the name and the price, because those are the two things that we're comparing up here. Hash those, produce a hash code based on the name and the price, and we're set. Already takes care of nulls, already takes care of you know, what works whether things are primitives or reference types. It's good. Problem solved. Everybody tracking with me there? Okay. So those are the three methods that we are built in to those are the three methods that are built into object. Okay, so we often have to override those. I could add additional methods in there as I want to. I think that part should be pretty self-explanatory. But you can see that what are the parts of our class? We've got constants, we've got instance variables, we've got constructors, we've got getters, we've got setters, and we've got methods. Keep them in that order. The Java language doesn't require them to be in that order. Keep them in that order because it makes it easy for other developers to read it. It makes it easy for other developers to read it and understand what you're doing. If you don't put it in that order, it's quite a bit more complicated to read. Okay? Everybody good with that? So if I'm going to fully implement a class, those are some of the things that I might put there. Now, if you looked at my example code, I kind of contradicted everything that I just said in some sense, not fully, but you might be asking, well then why in the, say the NPR News app that I wrote, why did I write this? Why did I do something like this? What's the story? Why was it okay just writing that out? So I hope you can see that this is 2 lines, and that is quite a bit more. That first part should be obvious, right? This is 2 lines, the other thing is quite a bit more. If I count it, this is line 79. Actually, I should count from 78 up to, well, I've got a lot more comments in there, but up to, so there's like 60 lines of code. I am counting comments and other things, but this is 60 lines of code, and that's 2. They are not equivalent. Let me just be clear about that. Those 2 things are not equivalent, okay? This is not implementing toString. This is not implementing equals. This is not implementing hashcode. All of those things have not been overwritten. So if I needed those, I would need to go do that. It just turns out that most of the time, you don't need toString, you don't need equals, and you don't need hashcode. It turns out for a lot of these data classes, we really don't care. Okay? And for a lot of the data classes, we simply don't care. It's not worth the time. Everybody good with that? We're writing a lot of these data classes, right? So saving a little bit of time is pivotal. If I had done this with all of these methods, this oftentimes results, I used to always code my stuff in this pattern. It meant that I was writing these classes. Oftentimes I'd come up with a project idea, write it out, do all these, and I never actually got to build the program because I was spending all the time rigging this stuff up. It's a pretty big cost to do all that. So I've started doing this more often. Okay, this is what I like to call a struct. I borrow that term from the world of C++, C and C++, where it's just a thing that contains data. Because that's really all I care about. I just want to hold on to some data. So I don't need the constructor in those cases because, well, what's constructing it? Well, JSON's constructing the objects. If I'm never calling and constructing one of these objects myself, then I don't need to write a constructor for it, right? I might as well just go with this. Because it has to have that default constructor anyway, okay? Other side of things, why did I need getters and setters? Why did I need these? Why did I need these four methods? Okay. Why couldn't I read and write the data without them? Yep, that's it. They're private. So because they're private, I couldn't read and write them directly. I just made them public. If I made them public, then I can read and write them without a getter and setter. Okay. Which saves me a lot of code. Okay. Again, that might seem like a little bit to type out. The good news is that IntelliJ can just generate these for you. There's a button that you can click, and it'll say, just give me all my getters and setters. It can do that for you. So there is a way around spending all the time there, but it's still time I have to maintain. So for instance, every time I add another instance variable or change one, I have to go change and update the getters and setters. Okay. So mainly the reason I'm doing it is to save development time, right? Save development time. The reason that's generally we follow this pattern is because of a big word called encapsulation. What I'm doing is encapsulating the name and price. I'm not making it publicly available. It's encapsulated in this product object. I can't get to it directly. Every call to get it has to go through these methods. Every call to set it has to go through those. If I make them public, then I don't really have control over that anymore. But it turns out for most of those classes in my data, I don't really care. If I'm just writing it like this, I'm not actually providing myself any additional encapsulation. Okay. It's only if there's some additional logic in there. That function would need to have additional logic, both in the setters and both in the getters, right? Otherwise, there's no point in having it. So we're tracking with me there? So for most classes, this is kind of where I've landed, is for most classes, it's kind of not worth it. And it's also just, oftentimes it's not worth doing all that. And B, I was trying to get you started faster. That's the other thing. I was trying to give you a faster way to get through the project. Okay, rather than focusing so much on classes at that point. Everybody good with that? Does that make sense? Kind of my motivations around that? I'm optimizing for developer time. Because remember, one thing to keep in mind is when we're talking about modern software development, the most expensive thing is you. You are the most expensive resource in your project. So optimize your time. Don't treat your time as a free commodity. If you're spending an hour writing that when you could have been writing this and it would be just as good, or you're spending an hour doing that. Okay, so I'm only going to do that in places where it matters. So for instance, you might notice when I wrote out the adapter, I can't. I made all those fields private. But when I wrote the view holder, I don't care. It's really just a holder for data. The only thing that has access to it is the adapter. So I just made it, I followed this pattern down here. Does that make sense? So you'll see me do both of those patterns. If you ever switch over to the world of Kotlin, Kotlin's actually addressed this in the fact that in the Kotlin world, they have data classes, which let you write out classes like this in the world of Kotlin. I can write it at the same brevity and get the whole impact of this in Kotlin. So Kotlin, you can actually write it this briefly and get that benefit. Java just doesn't have that syntax. So like in the world of, I think in Kotlin, I'm not really all that familiar with it, but it's basically you just add the word data and it works kind of thing, right? You get the thing above by just adding the word data. So that's what I'm trying to imitate. Cool. Everybody good with that? Okay. Other questions? So going back to here. Question was, can you go over class creation and class use? So does that first part make sense in terms of class creation? Okay. Are there any outstanding questions in terms of use? Right? Because I didn't really talk about use there. I just talked about the creation side of things. Any other questions about use? Okay. Cool. Did that help a little bit with the things that were outstanding? Talking about constructors, talking about getters and setters, methods. Okay. I'll save that, and I'll actually take all of this and bring it over. And I'm going to use my extension, add-ons, code blocks, start. This is Java format. One point. Okay. That one is 5. So another question I have here is, what are the main differences between the data and the UI layer? And kind of a corollary to that is, how should one go about separating the data and UI layers? Okay, so it's a really good question to ask. Okay, where I start is there's a few things that define what has to be in the UI layer. Okay, it's harder to define. It's hard to define what needs to go in the data layer. But it's actually a lot easier to find what can't go in the data layer. Okay, there's a bunch of things that cannot go in the data layer. Okay, so one of the rules about the data layer: the data layer cannot use views, activities, or context. Actually, context sometimes. Application context is the same. It can use an application context, but it cannot use an activity. It cannot use views. It cannot reference either of those things. And generally speaking, it also shouldn't be using live data or view model. Okay. So the things that say it can't be in the data layer is if you're using activity, view, some subclass of that. What was the other one? View model. And view data or live data. So generally speaking, which this one's kind of a weird one. Live data is kind of a weird one. But activity, view, or view model for sure, you can't reference those in the data layer. Okay. That's a hard and fast rule. Nothing in the data layer can use an activity, nothing in the data layer can use view. If you need to reference any of those, it has to go in UI. Right? Also, view model, anything in reference to view model has to go in the UI. Okay? So that's the first rule. I was going to write this out. Actually I'll write that. Main differences that on my list. So the first question, the first things, so the things I put on there. Write that on here. Okay. And throwing this out there, are there any other rules? Are there any other things that come to mind about what would determine which layer it goes into? What else would apply? So the weird case with live data is you generally should not be observing live data in the data layer, but it's okay to be exposing or providing live data. It may be okay to provide live data, but not read it. So like my connectivity data source is kind of a weird case. It's like, well, maybe it shouldn't be there, maybe it should, but it's exposing live data and not reading it. Or so what are some of the things we did put in the data layer? What are some of the things that you did put in the data layer? Michael. Hey, Michael. What was in your data layer for your UB Explorer project? What were some of the things that you had there? What classes? I'm going to jump over somebody else. David, what did you have in your data layer? For the eBix. Okay. So some sort of API, like maybe the browse API, right? I think most of you would have had 3 classes there. For sure you'd have the browse API, right? Some model for that. I also gave you a class. What was the class I gave you? You put there. Auth API. What else was there? Mm-hmm. And remember, there's also an auth environment that fell into there. Is there anything in common that we can say about those that would say that it needed to be at the data layer or could go into the data layer? Does it have anything in common?
APIs should go on the data layer.
Wow. So you're saying APIs should go on the data layer? Okay, that's a good statement, but why?
That's for the ones that like interact with like, the data.
Interact with the data. They're what we would call a data source. Okay, if it's something that kind of is a source of data, like a source of products, it's the browse API, a source of authentication stuff, like the data, then it does fit there, right? If its chief concern is with the data, then it fits there, as long as it has no connection to the UI. That's the critical part. It can have zero connection with the UI. As soon as you connect with the UI in any way, shape, or form, it's UI layer. Even the tiniest thing that connects you with the UI, you move over to the UI layer.
So something is like connected to both the data and the UI, the UI layer.
UI layer, yeah, which would be the view model, right? The view model messes with, has some relation with the view and activities, and also has some relation with the data layer. But because its relationship with the UI, it has to be in the UI layer. Okay, so it's really anything can go into the UI layer and not break the rules, but not everything can go into the data layer. Does that follow? Right? It's really what's in the UI layer, anything can be there, right? But we try to keep it a little bit smaller, like move things into the data layer to try and not have everything in the UI layer, right? So the whole thing about the data layer is getting things uncoupled, as we would say, unhooked from the UI. It's about breaking a part out that's reusable, that's not connected to other things. Does that make sense? So like auth environment, it's in the new. It just holds some data. It just holds the name of the environment and URLs for that environment. It's not connected with UI. Auth API, not connected with UI. Connectivity data source. It's connected to the Android device, but it's not connected to an activity, right? It's not connected to a single screen, it's connected to the state of the device. Cool. So as long as connectivity data source is connected to the application, it's okay. If it gets connected to an activity, it's a different story. Right? If it were connected to an activity, then it becomes UI layer. So you might notice when I wrote that connectivity data source, I was very, very careful to avoid a reference to the activity. Which is one of the reasons why it takes the connectivity manager. It doesn't take the activity or the context. Okay? The get system service call is over in the view model instead of being over in the data layer. Okay? Questions? Does that help somewhat in terms of knowing what goes there? Which side is going to have more classes? Is UI going to have more classes, or is data going to have more classes? Hands up for everybody who thinks that data is going to have more classes. Hands up for everybody who thinks that UI layer is going to have more classes. Hands up for everybody who thinks it depends. Okay, it's the latter camp. It depends. Okay, so it's usually going to be the UI layer. It's usually going to be the UI layer that has the most classes. Okay, but it depends. Okay, so one of the reasons that I got this down, and one of the reasons that I said only those 4, is because I presumed that it nested a few classes inside of these classes. Okay, so if I hadn't done that, well, browse API, in order to implement that, needed a browse like a service. It needed some sort of browse response or search response. You can see what was in there. We needed an item summary. We needed an item price, an item image, an item seller. Okay, so if I keep those as separate files, absolutely your data layer is going to have those classes. Okay, if you nest these classes inside of Browse API, it won't have the most files. Okay, but if you count for those, it's actually the data layer is probably going to have the most. But it still depends on what type of application you're building. Okay, so and it depends on what type of application you're building. It depends on how you count it. Does that make sense? So if you count all the nested classes, then there's probably going to be more in the data layer. But if you just count the top level files, right, more than likely it's going to be the UI layer having the most top level files. Cool? Make sense? Okay. What were some other things that were definitely in the UI layer? Well, the obvious one is main activity. All of your activities will definitely be inherently in the UI layer because they have to refer to activities in use. There's no way around that. They have to refer to activities in use. Oh, another item add in here. Fragments also push it into the UI layer. If you're referring to fragments, then that also puts you into requiring to be in the view in UI. So what else was in the UI layer? What were all the classes that we added for that project? Just list them off.
Adapter.
Okay, the adapter. What did you call your adapter? Okay, so let's say it's an item adapter. If I was calling it like I did above, right, I called them item summaries, so I might have called them the item summary adapter. Okay, and really it's not a single item summary, it's an adapter for a list of those. So a good name for that class would be item summary list adapter. I know that's long. I know it suffers from Lego naming. Unfortunately, that's the convention in Java, is to Lego brick a bunch of names together. So that's a conventional name. Another way I could name it is, depending on how I structured this, I might also call this a browse response adapter, if I just gave it the entire browse response rather than a list of item summaries. So it could be either, right? But the adapter for sure, right? What else was in there? What do you have to do with the adapter? does the adapter require? View holder. Okay. So what was the view holder holding? What was it for? Right. So the data class that it corresponds with is it's a representation of item something. Okay. Either name in this case is one I would be okay with. Item view holder or item summary view holder. They would be similar enough that either name is okay there. And actually this is probably, I would probably take item list adapter here too. But I would want to see one more word in there rather than just item adapter. Partly that is because oftentimes if I'm doing, say, array, then I would need a separate adapter for working with arrays that versus lists. I usually can't use the same adapter for both lists and arrays. So I do want to see that. All right, so activities, adapters, holder, view holders, anything else? Your model? Okay. So what did we call that class? So it's not view model because it's a subclass of view model. Okay, that's fine. Anything else in there on the UI layer? And there's at least one more class in there. Yeah, the app class. So I would name that similar. That would be my application. Okay. So all of those things fit into, these things for sure fit into the side of like, they have to always be in UI. Your activities, your adapters, your folders, view holders, your view models, your application, those things will always be under the UI. These kind of things are safe to put into there. Okay. So give me an example of something that you maybe aren't sure where to put. What's an example of something that you don't know where you would put it?
Well, I had main activity just data.
Okay. None of the activities can go to data. I think you had it at the root. Yes, that's at the root. Yeah. That's at the root. So I mean, that's leaving it at the root is something that's acceptable, even though technically it would be part of the UI layer. It's just that there's other things that happen when you try to move it. So that's where I'm okay with it, is because problems come up when you try to move those activities around. Android Studio doesn't like that, per se. Okay. So activities, other things, another thing would be in here. Would be fragments. Or if you had custom views. If I had made like a special view, like some sort of date selector or a carousel, any of those kind of things would be considered the UI layer, for sure. What about exceptions? What layer does a custom exception fit into? Is an exception UI or data?
I don't think an exception has anything to do with like the UI.
The exception shouldn't be referencing any of these things. Okay. Generally speaking, it's only got like a message in it, a string. It's like, here's the message, here's the error message. And if it is referencing other things, it's generally just going to be like primitives, strings. Some of these data classes could be okay. Yeah. In general, an exception would go into the data lake. In general, anything that's a model class, that's where it's going to represents data that's maybe in a database or a file or coming from the network. Any of those model classes, those would be considered data because they hold data. Cool. Okay. Any questions on the layering? Does that help? Maybe the big rule, as I've said, the thing to remember is what are the things that can't go in data, right? The whole idea is to put something into data, you have to remove references to other things. You have to make it a block that it can be standing outside of those other things. Okay, let's go take a break. And let's come back. We've actually run a little bit long here. I'm okay with that. And let's come back at 3:30. Okay. Or what tasks should be performed on the main and background thread? Okay. So the first starting point is if you don't care about how poor performance your app has, in theory, you could do everything on the main thread. Historically, we used to do everything on the main thread. Like that used to be the de facto way the programmers wrote code. Okay. We have found with time that doesn't produce a good user experience to do everything on the main thread. Okay? So the stipulation is we need to reserve a refresh rate of 60 hertz, 60 frames per second on the screen. That's what we're trying to achieve. We've got similar stipulations with audio also needs to be rendered at a certain rate. Okay? So what we're trying to achieve is keep that stable. Okay? That's the end goal, is we want to keep it so that the main thread is available to do all its work. Okay? In order for the main thread to be able to render at 60 frames per second, it needs to be rendered every 16 milliseconds. Every 16 milliseconds, it needs to render a frame. This is called the frame time. So you got the frame rate is how many frames per second, but the frame time is how long between frames. And it's actually, that's even more important than frame rate because what your eyes actually see is the frame time, not the frame rate. What you perceive as a drop, as a stutter, is a frame time that's long, that's too long. If the frame time is significantly longer on one frame than others, or shorter on one frame than others, that's what your eye sees. And that's perceived as jank or stutter. It's not a good experience. Okay. If it gets too long, right? If you start blocking the main thread for seconds, say it's blocked for 30 seconds, the user can't interact with UI at all for that 30 seconds, right? So you're trying to keep it responsive. Everybody good with that? Clear? So our stipulation is 16 milliseconds. Okay. So if we slow that down, if we're making the thing stutter, then we need to move things to the background thread. If we're going to cause it to stutter or lock up, then you push things to the main thread. At what point do you cause the main thread to stutter? Well, if it takes 2 milliseconds or longer, that's about a good metric, right? Look at the code, measure how long it takes. If it ever takes 2 milliseconds or longer, it needs to go to a background thread. Even if that's rare, even if it only happens in a blue moon, even if that only happens on a poor connection, maybe it only is that slow on 3G, maybe it's only that slow if the network's disconnected, maybe it's only that slow on a really cheap device, or the GPU is cheap, or low-end GPU, low-end CPU, limited memory. If there's hardware limitations where that doesn't work, then you should move it. So the best way to kind of determine whether it should be on the main thread or the background thread is actually just to test it. To test it and time it. Okay? Test it and time it. But the important thing you have to do is test it on as many devices as possible, because even if one of your customers is that slow, well then for that one customer you need to move it over, because they're not going to be the only customer that has a device. So a lot of it comes down to measurement, and that means it's helpful to know some things that are heuristics as far as, what are the things that can take longer than 2 milliseconds, okay? Well, we know network communication always is longer than that, okay? If you looked at a speed test, most people's ping, how long is most people a good ping? What is a good ping? Huh? 40 is actually high. A good ping is 10 milliseconds. How long do we have? 16. Okay. So just to clarify what a ping is, a ping is sending some data to the server and it coming back. Here, there, back. Trick is, a ping is usually done with the smallest amount of data as possible. So if I can send 1 byte or 0 bytes there and back, how long does it take to send 1 byte there and back? Okay, a good ping is 10 milliseconds to go over the network. 40 is more average, okay? Even a ping would slow this down. So that means anything that goes over the network, doesn't matter what it is, has to go to the background thread. That's why the rule exists, okay? Because the only case where anything network related would be fast enough to fall into that 2 mil, to like be anywhere near 2 milliseconds or less, to be under 16, would be if you were either talking to yourself, talking to localhost, which you're probably not doing. You're probably not talking to the server on the phone itself, or it's some sort of internal network, some sort of intranet, where it's your company's thing, and you're going from your device directly to something that's on the same network that's in that office. That's the only case where you might find something under 10 milliseconds, really. Okay? Because even going from, say, one side of the country, going from California to New York, you're going to find there's delay just doing those kind of things. Cool. So anything network related, for sure, is going to take long enough that we should move it to the background. What are some other things that take long times? What are some other things that take potentially 2 milliseconds or more? So an event handler shouldn't, because let's say you have a click handler, the UI is completely blocked until that function returns. That event handler needs to be very fast. Okay, it shouldn't be slow. So we're moving things to the background thread to make sure those event handlers aren't slow. Right? So that's part of what we're trying to do. So we're trying to not make the event handler slow. What would make the event handler slow? So I'm going to list off a few things. Things that are slow. So for sure network, files is another one. So network I/O in general. File I/O is also potentially slow, because how big can your files be? Okay, let's say I'm trying to read a 4 gigabyte file. That's going to take some time. Just reading, not even processing. If I want to open a 4 gig image, it's not going to immediately open up. Right? If you've ever tried to do some large images in Adobe, try to open up a large file, you've seen it take some time. We call also in there things like streaming, audio, or video. Those are going to be things that involve background threads. They're running over a longer period of time and they're not cheap, because oftentimes they're also involving network and files, right? One or the other. Either you're reading the video from the internet or you're reading the video from your computer, from your device. Either of those are going to be slow. Anything that has to do with the database. Is going to likely be slow, because databases are complicated beasts. So whether you're writing data, whether you're reading data, either of those things can take some time. Cool? Anything else? Do you remember the counter app that I showed you? Where I said, I'm just going to count from 1 to 1,000,000 and write that out to the screen. Do you remember that Android not responding dialog that popped up? That's because it was taking too long. But in that app, I didn't have any of these. What made it take so long that it took several minutes for it to process? It wasn't one of these. Why did it take so long to count from 1 to 1,000,000? One thing, remember, how long did it take to count from 1 to 1,000? It's almost instantaneous, right? It's almost instantaneous from 1 to 1,000. It was really slow from 1 to 1,000,000. Why was it slower? Well, because the loop was iterating longer. So a thing that can make it so slow that you have to push it to the background thread can just be a really long loop. Like that's it, right? It could be a really long loop, right? If I'm trying to have a loop that's going to take a long time to operate, that's enough to run into, hey, this can take 2 milliseconds or longer. It needs to go to the background. Cool? Okay. In fact, that actually covers most things, because part of the reason that there's 2 reasons network I/O is slow is because A, first of all, you have to deal with the network, and B, because it usually involves loops. Same thing with files. It involves the file system, which is slow inherently, and dealing with the hardware, which is slow inherently. It also deals with looping through said file, right? And so if I'm looping through a 4 gig file, that's, for all intents and purposes, looping to 4 billion. Just looping from 0 to 4 billion is going to take a long time. Okay? So a lot of these things involve loops, right? And so usually a good thing to look for, if you're seeing something that needs to go to a background thread, there's probably a loop somewhere. right? So pay attention to anything that has a loop. If that loop starts to get to the point where sometimes it takes 2 milliseconds or longer, background thread it goes. Does that make sense? Does that help? So really what you're looking for is loops. Is you're looking for slow loops or looking for blocking, right? So long loops, blocking, synchronous, APIs. Blocking or synchronous APIs, which is somewhere where there's a rule. Okay. A common one that I see that people forget is parsing JSON is often something you need to put to the backend. That's oftentimes an overlooked one. Why? Why could parsing JSON take a long time? Does parsing a JSON string involve a loop? Yes. Right? So if I take this long string of JSON and I'm trying to turn it into objects, I have to loop over said string. So if I'm getting a megabyte of JSON data, it will take a long time to parse that data because I have to loop through and process all of that data, right? If you're parsing a very small amount of JSON data, it's almost instantaneous. It's almost instantaneous. But if I try to parse a large amount, that takes a long time. So, and that's oftentimes a piece that people miss, is they say, oh, I'm going to do this parsing the JSON, and I've even seen this in their own documentation for different things in Android and retrofit. It's like, oh, we'll just do the parsing, we'll just do a parsing on the main thread. No big deal, right? But that can be something. So, but it's usually again something that comes down to testing. Is you build it, you work with it, you test it, and then you find out, oh, my application's running slow, there's jitter. Let's go profile it and find out. Well, we find out that this part is slow. So sometimes you can anticipate it if you know it falls into one of those categories, but usually you're just going to, oftentimes you may find it after testing. Cool. Does that answer everybody's question? The threshold you're looking for is a small number of milliseconds. Because even a millisecond is a long time for a computer. Okay. There were some other questions on the board. I've added them to this document, and so you can review some of those off camera because most of them are pretty short. One I did want to mention real quick is, does Picasso work with videos and GIFs? And the short answer is no, because image view only supports pictures. That's why. So in order to deal with videos and animated GIFs, you actually need another library. You need different tools to do it. And I don't know that there's a library that I'm aware of that can deal with video and animated GIFs out of the box. I think that that's something, unfortunately, you have to build custom. So there's a lot going into things when you see animated GIFs online or in programs. It's not an easy thing. So I'm gonna share that. Copy link. So I'm gonna do